Everyone, please join now. And who have any question or doubt, please ask just after the finish of my class. Okay. Whenever I say now you can ask a question, then you can ask. Okay. You can note down if you have any doubt. You can just note down, and at the end of class, I'll give you some time. At the time period, you can ask your question. And if I see it's relevant to the particular course and the topic that I'm discussing, of course, I'm going to answer this. Okay. Please inform everyone to join. Okay, let's wait 1 2 minutes. Okay, let's wait for everyone to join. I'm coming back. I'm going to drink some water. Okay. Okay. Let me share my screen. Yeah. So yeah. So depending on the site condition, whether there is water present in the voids or not. Okay. Depending on the presence of water, we can have three stage of soil. A soil may be in a dry state, that can be known as dry soil. A particular soil may be in a fully saturated state, where a particular void, all the voids are filled up with water. And the third one is, you can say, partially saturated state. Sorry, partially saturated soil. And this partially saturated soil have that's all the three components, that is air, water. Okay. Now, in a different way, you can see here in the first diagram, the second diagram, you can say, in this diagram, we have all these three components present: air, water, solid. In the third one, you can say there's only two components are present: solid and water. Again, if you go to the last one, again, this dry soil is in, again, two components are present, that is solid and air. From this diagram, what we can observe, first observation is what? That whatever stage may not be there, okay, whatever stage will be there, one thing is always will be there permanent. What is the permanent thing? This is solid. Solid हमेशा रहेगा. Okay, solid will be remain there only. So if you are not, if there is no any external disturbance, even the volume and voids of the solid will not change. Can you see the diagram also? There is same diagram is presented here. Solid, solid, solid. Any stage you can consider. This is the first observation. That is, solid will be there permanently. After it, if you say this diagram, here we have solid, water, and air. This is basically known as three-phase state. Okay, this one and the last one both are two-phase state because there are two components are present, right? So in exam, question be like coming like, for example, say dry soil is in which state? One, two, three, four. Option will be there. What will be the answer? Can you write in the chat box? Just write in the chat box. Let's see. A dry soil, I'm giving the question. Dry soil is in which state? I'm writing this question, okay? Dry soil is in which state? Where is the question mark? Wait. I'm giving the dry soil is in which state? Giving answer question, sorry, option. One, two, three, four. These are the options. So can you answer it? Type it. One, two, three, four. They are option. Okay. Dry soil is in which state? Reply. Anyone? कोई तो बोलो.
Four.
लिखो, type करो so that I can see who is answering. 4. How can you say 4? 4 कैसे हो सकता है? यहाँ पे क्या लिखा है? स्क्रीन में क्या लिखा है? Soil is as three phase diagram, three phase system. टोटल तो 3 है, 3 के ऊपर तो होगा ही नहीं, तो how can it come 4? क्वेश्चन को अच्छी तरह समझ लो. इट इज नॉट दैट कॉम्प्लिकेटेड. मैंने क्वेश्चन क्या पूछा था वो पहले देख लो. I'm asking what? I'm asking dry soil is in which state? Two phase or three phase or single phase or four phase? I'm asking that only. Now answer. डायग्राम के बारे में नहीं पूछ रहा हूं. If you are mentioning diagram number 4, I'm not asking the diagram number. I'm asking which phase. Every component represents individual phase. Okay, air is a phase, water is a phase, solid is a phase. From the diagram itself, you can understand, right? A dry soil is in which how many stages? Phase कितना है उसका? Yes, two phase ना? It's a two phase state होगा ना उसका? A dry soil is in two phase state. That means one phase हो गया solid, another one is your air. If I tell you partially saturated soil is in which state? It will be in a three phase state, right? Fully saturated soil is in which state? Fully saturated soil is in two phase state. क्वेश्चन और ऐसा भी आ सकता है कि fully saturated soil में क्या होता है? Okay, I'm writing some question. What are present in fully saturated? Oh, क्या आ गया ये? What are what are present in fully saturated soil? क्या क्या है बोलो तो मैंने क्वेश्चन दिया है. ऑप्शन कुछ भी रह सकता है. एयर वाटर soil solid and water, soil solid plus air plus water or solid plus air. क्या हो सकता है? Yeah, in fully saturated soil ऐसा मत लिखो, soil मत लिखो, confuse तुम confuse हो गया, soil मत लिखना. Soil, if you say only soil, it will consider as a whole, right? Soil solid. The answer is क्या? Answer होगा soil solid and क्या? Water. Okay, soil solid and water. Okay, don't write soil, only soil, because soil actually represents whole soil mass. Specifically, you have to write soil solid or soil grain. Okay, I think these things are clear, right? Okay. So yeah, whatever we have discussed in terms of volume and in terms of weight, these are things are present here. I think these things are also clear to you, right? A schematic diagram of the three-phase system. Suppose it is a partially saturated soil where solid is present, water is present, and air is present. Now, if you represent the weight and volume of individual component of a particular soil mass, it will be like this. Okay. If somebody asks you to draw a three-phase diagram or phase diagram of partially saturated soil, it will be like this. Okay. This is in terms of this is in terms of weight. Okay, कहाँ गया? Wait. कहाँ गया? Okay, here. This is in terms of weight. This is in terms of volume. Now, if you consider volume, here you can see this V represents total volume. Okay, and Vs represents volume of solid, and this Vw represents volume of voids. And this volume of void is a summation of volume of water and volume of air. Correct? And total volume of voids plus volume of solid represents what? Total volume. Okay. In other hand, see, this is your weight of solid. Okay, this is weight of solid. And from here to here, whatever it is, from here to here, this is what represents weight of water. Okay, this represents weight of air. Okay. Now, can you see some error here? Can you identify something is wrong here? What is wrong about this diagram? Can you identify? See closely what is little bit of correct. Can you identify anyone? क्या हो रहा है यहाँ पे क्या गलत है? Not गलत है actually, but something is not right about this diagram? Is there any wrong?
The weight, sir.
Weight means what? Can you explain it?
The total weight.
Yeah, good. Very good. So can you see this total weight it is not coming to the top one. It is just up to this water, right? Because in case of soil mechanics, you can say this weight of air is neglected. It is considered as zero. Though in soil mechanics, the weight of air is not considered. Okay, fine. So that's why if you going through the in terms of weight, the air is considered as weightless. Okay, that's why when it comes to total weight, it will always summation of weight of solid plus weight of voids. Okay, weight of void, but the weight of voids is basically summation of weight of air plus weight of water only. You know these things. Okay, but here the weight of air is neglected. That means it is considered as a weightless. So the weight of voids is basically equal to weight of water, and total weight will be equal to weight of solid plus weight of water. Okay, but it is not the case of volume. In terms of volume, there is a volume of air, but in terms of weight, the weight of air is not considered. Okay, since it is very negligible. Okay, okay, yeah. So okay, so I think we can stop here. Okay, so about the some parameter like void ratio, porosity, degree of saturation, air content, percentage of air voids. Okay, let's discuss these things and then we can conclude. Okay, let's discuss this. I'll tell you about it. Okay, so anyway, there are some parameter based on phase diagram. So if you understand this phase diagram, if you can understand this phase diagram, from this phase diagram, we can find some parameter of soil. What are the parameters are there? Like void ratio, porosity, degree of saturation, air content, percentage air voids. These are some parameters which can be derived from this phase diagram. Okay. Now just see closely here. Wait a second. Okay. Now what is void ratio? First of all, void ratio is represented by the letter small e, and it is the ratio of volume of voids to the volume of soil solid, and it is expressed as decimal or fraction, and representation is what? E is equal to VV by Vs. Okay, so if you know this parameter, volume of voids, this parameter, all these parameters, if you know, you can find the void ratio. What is void ratio? It is a ratio. Void ratio is the ratio of volume of voids, that is VV by Vs. Now let's go to the diagram. VV, this is the VV, right? This is the VV, volume of voids divided by Vs. Okay, volume of voids divided by Vs. It will give you what? Void ratio. Okay, VV by Vs give you void ratio. Next, porosity represented by this letter small n. It is the ratio of volume of voids to the total volume. Okay, and it is expressed in terms of percentage. That's why a multiplication of 100 is given here. And what is the ratio? Small n is equal to VV by capital V. Now let's go in the diagram. This is the VV, that is your volume of voids divided by total volume. VV divided by total volume, it will give you porosity, that is small n. Clear? And it is expressed in terms of percentage. Now there is a relation between void ratio and porosity, and how they are related. small e is equal to n divided by 1 minus n. Okay, just remember these things, or you can also remember this one. But one one relation is enough. Okay, from this you can derive this one. So whatever you want, you can remember this. And this is a very important relation between void ratio and porosity is very important in terms of exam point of view. I'm not even your semester exam, even after your completion, the competitive exam also question may come related to this relation, void ratio and porosity. So E is equal to n by 1 minus n. Okay. After that, degree of saturation. So what is degree of saturation? Denoted by capital S. It is a ratio of volume of water to volume of voids, and it is expressed in percentage. Volume of water by volume of voids. Volume of water by volume of voids. It will give you degree of saturation. That means how much water present in the voids, it gives you degree of saturation. Okay, degree of saturation means what? How much water, what is the volume of water present in voids, it will basically represented by this degree of saturation. Okay, it is expressed in percentage. Now, if you consider for dry soil, since in case of dry soil, the volume of water will be zero, degree of saturation will come as zero, right? For fully saturated soil, since volume of water will be equal to volume of voids, what you can understand that degree of saturation will be 100%. So we can say that the value of S, wait. The value of S will lie between 0 to 1, or you can say in percentage the degree of saturation lie between 0% to 100%. This is also very important information about degree of saturation. Okay, next, air content denoted by small letter a suffix c small c. This air content represents what? Volume of air uh, in voids, basically. That means how much volume of air present in the voids, it give you air content. Okay, and it is the ratio of volume of air by volume of voids. If you go in the diagram, that means what is the air content? Volume of air by volume of voids. It will give you air content. Okay. So if you see the diagram, the volume of water present in voids given by degree of saturation, volume of air present in voids, it gives air content. Okay. From this we can say that degree of saturation, that is S plus air content, is equal to 1. This is also very important relation. Okay. See, so consider this is 100%. From this 100%, suppose 60% of water present. Now, how much air will be present? Of course, 40%, right? From 100%, you can just subtract the other one. You will find another one, right? So we can say that degree of saturation, the summation of degree of saturation and air content is equal to 1. Okay. Mathematically also, we can prove this same. Okay. And the percentage of air voids represented by Na, small letter Na, and it is the ratio of the volume of air to the total volume. Okay, can you see the difference between the 4 and 5? Air content is defined what? It is a volume of air with respect to volume of voids. Denominator, can you please concentrate on the denominator? But the percentage of air voids, it represents what? Volume of air with respect to total volume. Okay, and also it represents in terms of percentage. Fine. So let's go back in the diagram. Percentage air voids, it represents volume of air by total volume. So volume of air voids divided by total volume. So it will give the percentage air voids. Okay. And this represented by VA by total V into multiply by 100. And the relation between air content and a percentage air void is what? Percentage air void is equal to small n multiplied by AC. Now what is small n? Small n is your porosity. Small n is your porosity multiplied by AC. AC is what? Air content. You can also check mathematically. Okay. Put the value of Na, put the value of Na, sorry, put the value of N is what? VB by V. Okay. Then if you multiply this thing, that is VB by V, with what? With this VA by VB. Finally, we'll get the percentage air void, that is Na. That's why this relation comes. Na, that is percentage air void, is equal to porosity multiplied by the air content. This is also a very important relation. Okay. So these are the parameters based on the volume of a three-phase diagram. Okay. These parameters are very important. So with this, I just want to close my class today. Okay. 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 So if you have any doubt, you can do one thing. You can just text me. Text me. I'll answer it. Okay. With this, I just want to close my recording here, and after that, um, we'll close it.